Welcome to this tutorial for using JASP for multiple linear regression. So what I'm using for this tutorial is the Honda Elements file. You can see the completed process already here. So I'm going to also explain how we get there. But the idea is basically that we want to predict how asking price depends on other variables. And there's basically two quantitative variables, which are the covariates, year and miles, and then three categorical variables, which are called the factors. And basically, the information on how asking price depends on those factors is given in this coefficients table. But before we get into this, let me just maybe get all of this, undo all of this so we can kind of start from scratch here. So if I bring all those factors back into the variable list, we have this. So this would basically be your starting point. Of course, you would have to, I can close this as well. If you start with the actual data, which you can see here, you would have to go to regression, linear regression, and then we would basically come to the screen that we've seen before. So I'm basically selecting asking price as my dependent variable, and then I'm using year and miles as my covariates. So again, these need to be quantitative variables for this to work. And then I'm going to use drive, dealer, and region as my factors. So for this class, the factors only have two levels, which simplifies things a little bit. And basically, as you can see, the output is what we kind of started with. We're kind of interested in two things. One of them is this R squared here. So this is the R squared for M1. So this basically tells us that the model of predicting asking price using the 5 variables that we have here explains about 84% of the variation in asking price. So it's a pretty good prediction. Only 16% of the variation is unexplained by this model. So that's one thing we're interested in. And then the other thing we're interested in is these coefficients here down in the coefficients table for M1. So specifically, the coefficient for year tells us that the asking price is predicted to increase by about $1,000 for each additional year. So that is sort of the effect of year on asking price. And you can see from the p-value that prediction is significant. So in other words, that's a real effect that year has on asking price. Similarly, for miles, we have a negative number because we expect the asking price to decrease as miles increase. And the model basically tells us that we have a decrease of about 4 cents for each additional mile, which is again significant. It's not a big number, but it is significant. And then we also have the effects for those categorical variables with two levels. So the way to read this is that whatever is in parentheses here is not the base level. So if you go back to the data and you look, for example, at drive, the way it appears here is that the first level is four-wheel drive, which is the base level. And the second level is two-wheel drive, which basically means if we go back to the analysis, it tells us that if we go from four-wheel drive to two-wheel drive, our asking price is predicted to decrease by $400, as we would expect, right? Because four-wheel drive cars should be more expensive. Unfortunately for us, this variable, the effect of this variable is not significant, so it's not a real effect. Similarly, for if we go from no dealer to, if we go from yes dealer to no dealer, our asking price is again about $850 lower, as you might expect to pay less from a private person. But again, this effect is not significant. And finally, we expect to pay about $400 more in Denver than in the base level, which is Los Angeles. And but again, this association is not significant. So that's kind of how we do multiple linear regression in JASP and the interpretation. I hope that made sense. Hope it is also clear what you have to do for your own for the assignment that you actually that's based on the Candy data. Thank you.